Hey guys, so I always start the video with that. Sorry. Hello everyone. Today we are going to be writing equations. So far in this unit we've just learned how to solve them, but really we haven't learned about why that's important or why we use equations or when we use equations. So today we're going to look at real world situations and turn them into equations that we can use to help us solve for real world problems. So if we think back to what we did with expressions, this is going to be very similar to that, but now they will be set equal to a value, and we will be able to solve for the variable. Okay, so expressions, we just ended up with something like 2x plus 6. With an equation, we'll end up with 2x plus 6 equals 7, and then we can solve for x. We can figure out the answer to the problem. So for example, if there were 27 fish in the tank at the pet store and x were sold, that could be represented with the expression 27 minus x, and you can't really solve that. It just, depending on what x is, then you can solve it. But in the form of an equation, if there were 10 fish left, then how many fish were sold? So there were 27, some were given away. That equaled 10. There were 10 left over. So given that scenario, it can be represented with this equation. And then we can find the solution, x equals 7. That's how many fish were sold. Another thing, the word is means the equal sign. If you see the word is, that means equals. Look out for other words that would mean equals, like altogether or the amount left over. Things like that are gonna mean the equal sign. And then also, really, there's not like a method to this madness. You just kind of have to read and reread the problem. But the one thing that we do have to do first off is define the variable. So like here in this equation, we have the variable x, but we have to write what that represents. And in this case, it represented how many fish were sold or were given away or whatever. Okay. So again, really the only thing that we're going to do here is just go through some examples. Again, there's not really a method since all real world problems are going to be a little bit different. But we're going to start by defining the variable, reading the problem, and figuring out how to build the equation from there. So all of these examples are examples of one-step equations. These first two are not really real-world problems. They're just more verbal descriptions of an equation that we're going to translate into symbolic form. So the product of 15 and a number is 75. So product means multiply. The product of 15 and some number would be 15 times some variable, which could be represented with x, is 75. We said is means equals 75. So that would be the equation, and to solve this we would divide both sides by 15, and that would give us x equals 75 divided by 15 is 5, I think. Let me check. It's 5. All right, let's go over to this next one. Again, it's not a real world problem. It's just kind of a sentence that will turn into an equation. 4 less than a number is negative 15. So remember, when it comes to less than, we have to think about what the order is. If I want 4 less than a number, then I need to take that number and subtract 4 from it, equals negative 15. So that would be the equation. And to solve it, I would want to add 4 on both sides, which would leave me with x equal to negative 15 plus 4, different signs subtract, you get negative 11. All right, let's go to this middle example. You and your 3 friends, so that's 4 people altogether, go out to eat. you split the bill evenly. Find the total cost of the bill if each of you paid $8. So first we want to define the variable. What's the unknown in this scenario? So the unknown, what we want to find is the total cost of the bill. So you can choose the variable. I like to use the right letters to represent what we're talking about. So I'm going to use T for total cost. So we have this total bill. We divide it amongst 4 people, and we end up paying $8. So hopefully you can kind of hear the equation being set up. T divided by 4 equals 8. So that's the equation with the variable kind of in the mix. You might think about solving this problem just by doing 8 times 4. That's another way to think about it. And that's another possibility for the equation with the variable already isolated. So T, our answer, is going to be 8 times 4. So technically that's another possibility. This is the one that I'm more so looking for, but I do accept either one. And then to solve, either way, the total bill is going to be $32. Okay, if you started with this equation, you'd multiply both sides by 4 to get T equals 32. And here, T is already isolated. 8 times 4 is 32. Okay, let's go down here. James goes to the ATM and withdraws $40 from his account. He now has a balance of -12. Write an equation to represent how much money was initially in James' account. So the unknown here is how much money James started with, how much money was initially in the account. So I'm going to use the variable M to represent money originally in an account. So read and reread the problem. There's originally some amount of money in this account. He withdraws $40. He takes $40 out, so he subtracts 40 away from it, and he now has a balance of -12. So that's one possible equation. You might also think of it with the variable already isolated, like I talked about up there. Like maybe you think, well, if he ended up with -12, then he would have had 40 more than that before he took out that money. So that's another way to represent it. Either way, you get the value to be -12 plus 40. Different signs, subtract again, you get $28. Okay, and then over here, Kira has 28 books and Sam has X books. All together, they, I should say they, my bad, have 50 books. Write an equation to represent how many books Sam has. So define the variable. What's unknown is how many books Sam has. That's what we want to find out. So B would be books Sam has. So Kira has 28. Sam has some more. When you put those together, when you add those up, they add up to 50 books. So that's one equation that could represent it. You may have also thought about it with the variable already isolated. So if there's 50 in total, and Kira has 28 of those, you might have thought to get it using subtraction. Either way, you get B equals 22 books. That's how many Sam has. All right. So those are examples of one-step equations. Again, those are, it's easy to think about it in terms of the variable already isolated. As we go on to the next page with two-step equations, it might be better to just consider the equation with the variable in the mix already. So let's go ahead and get started. Cam bought Miss Marino boxes of chocolate for Christmas. They were $6 each, and she used a coupon that took $1 off her total bill. Her total bill came to $23. Write an equation to show how many boxes Cam bought. So the unknown is how many boxes Cam bought. We want to find that amount. So I'm going to say that B equals boxes bought, boxes of chocolate bought. So we know that they were $6 each. So $6 for each box minus $1 for the dollar off coupon, that totaled up to, that equaled $23. So hopefully, again, you can kind of hear the equation being built. It was $6 per box, so $6 times the amount that were bought minus the dollar coupon to end up being $23. So there's the equation. You may also think, with the variable already isolated, a different thing, and if you do, that's okay, but this is all I'm going to put up here for now. To solve this equation, we would add 1 to both sides. That would leave us with 6b equals 24, and then divide both sides by 6 to get b equals 4. B equals 4 boxes of chocolate that were bought. All right, going over here, Nick wants to buy a new sound system. He already has $65, and he gets an additional $20 for each lawn that he mows. So we want to write an equation to show how many lawns he needs to mow in order to have enough money for a new sound system at $145. Okay, so the unknown is how many lawns Nick needs to mow. So I'll say that I don't like using the variable L because it kind of looks like a 1. So I'll use M for lawns to mow. All right, so he already has 65. He gets an additional $20 per lawn mowed, and he wants that to equal 145. So there's an equation. To solve it, we would subtract 65 from both sides. That would leave us with 20m equals 80. And then when you divide both sides by 20, m equals 4. So 4 lawns Nick would have to mow. Again, you might think of it with the variable already isolated. Maybe you already thought that it would be 145 minus 65 divided by 20, which is fine, and that's actually what we did to solve the equation, but that's the only one I'm going to put up on the board. All right, one more. Hopefully you're still with me. It says Raymond just got done jumping at the Super Bounce Trampoline Center. He had to pay a $7 entrance fee and $2 for every minute he was on the trampoline. The total cost of the session was $43. Write an equation to determine the number of minutes he jumped. So we want to know how long or how many minutes he jumped. So I'm going to say that the variable n stands for minutes jumped. So he paid $7 to get in and an additional $2 per minute that he jumped, and he spent altogether $43. So that would be the equation that would represent the scenario. And then to solve it, we would want to subtract 7 on both sides, leaving us with 2m equals 36. Yeah. Okay. And then divide both sides by 2 to get m equals 18 minutes. Which is kind of a ripoff if you think about it. 18 minutes to jump and spent $43. So, all right. That's all I got. Your time to practice.